Thank you so much, Pam, and hello everyone. It's great to see so many familiar faces again. I'm actually speaking to you from Svalbard today. Just a quick note on that, we've had the warmest, second warmest month of February here on the archipelago. We've had rain, we've had temperatures up to +4 degrees. So it's only fitting that we talk about cryosphere and mountain glaciers together today. And I'm going to share my screen to take you through this study that just came out that Pam mentioned, the GlaMBIE study that came out 2 weeks ago in Nature. That was a massive global community exercise to bring together in situ remote sensing data on glaciers and assess how have these mountain glaciers changed between the years 2000 and 2023. They have produced an amazing video to explain how all of this data was brought together and homogenized. And I'm going to show you the video now. It's about 4 minutes long. Please let me know if you can hear the sound because it's totally worth it. And it was produced by ESA, the European Space Agency.
There are more than 275,000 glaciers located in mountain ranges, from the tropics to the polar regions. Glaciers are highly sensitive to climate change, and their melting clearly illustrates the impact of ongoing atmospheric and oceanic warming. Loss of glacier ice causes global sea level to rise, depletes regional freshwater resources, and increases the risk of local hazards. Monitoring glaciers is important for understanding the impact of climate change and accurately projecting future freshwater resources and sea level rise. Traditional methods of monitoring glacier changes on the ground are restricted to a few hundred glaciers worldwide, but global monitoring of glaciers is now possible using satellite observations. There are several techniques available, each with their own strengths and limitations. Stereo imaging and radar interferometry produce detailed digital elevation models. Repeat mapping, typically 5 to 10 years apart, allows changes in elevation to be measured. Radar and laser altimeters measure the elevation of a glacier's surface with great vertical precision, but require extrapolation to cover a full glacier. This can be done at monthly or annual time intervals, but there are gaps between satellite footprints and ground tracks. Satellites measuring Earth's gravity field can directly measure changes in ice mass, but at a very coarse, spatial scale. It is also a challenge to separate the glacier signal from other hydrological components. In a community effort, the Glacier Mass Balance Intercomparison exercise, GlaMBIE, compiled all major studies using these different techniques to give an estimate of the world's glacier mass changes over the last 2 decades. In total, the world has lost 5% of its glacier ice since the year 2000. But in some regions, almost 40% of the ice has gone. Ice melting from glaciers caused sea level to rise by 18 millimeters between 2000 and 2023. This is expected to increase to 32 to 67 millimeters by 2040. The world is currently losing 273 gigatons of glacier ice each year. That's about the daily water intake of every person on Earth for 30 years. The GlaMBIE project provides a new glacier observation baseline, allowing improved projections of freshwater resources and sea level rise.
All Right, truly an amazing piece of work, and I wish we had videos like these for every paper that people publish in glaciology, but this is certainly amazing material to share. So lots of numbers to remember from this study. I think some of the main ones are that mountain glaciers have lost about 5% of their volume just between the year 2000 and the year 2023. Some regions are, of course, responding much faster, much stronger than others, and that was also mentioned in the video. If we look, for example, at the maximum amount of mass loss, of regional mass loss, this actually comes from Alaska. This is where glaciers are still absolutely giant, but glaciers are also there responding really rapidly to climate change. So obviously, the sheer amount of ice lost by Alaska is gigantic. But if we compare the amount of mass lost to relative to the volume of ice left in those different regions, actually the European Alps and the Pyrenees are the two places where we have the largest relative mass loss. About 40% of the mass of ice has been lost over these 23 years, which is absolutely beyond dramatic. Obviously, it varies a lot from year to year, but you might remember that Swiss glaciers, for example, lost about 10% of their volume in only 2 years. So things are really accelerating. Let's remember what are the consequences of the loss of mountain glaciers. Well, first of all, we do know that mountain glaciers still matter tremendously when it comes to sea level rise. Together with Greenland and the Antarctic ice sheets, they are essential drivers of sea level rise around the world. And actually, what's fascinating about this study is that it reveals that since 2000, mountain glaciers have actually lost more ice than the Greenland ice sheet, and more than twice that of the Antarctic ice sheet. About 18 millimeters of sea level rise can be attributed from mountain glaciers since the year 2000. The loss of ice can also lead to devastating geohazards. This is, for example, the collapse of a glacier in the Dolomites in northern Italy only a few years ago. There was simply a giant water pocket that formed internally, and the entire thing collapsed, creating this giant tsunami in the mountains, killing 11 people on the spot. Also, glaciers matter because, as you know, glaciers and snowpacks are some of the best water towers we have in the world. We use this water to produce hydroelectricity, for sanitation, for drinking, for industry, for agriculture, for tourism. Also, in some countries, to maintain the discharge of the largest rivers during the summer months. Today, we estimate that about 700 million people rely on these freshwater resources directly, seasonally. But if we zoom out a little bit, it's literally billions of people who depend on meltwater from snow and ice. The study also touches upon this comparison. So trying to see if we have until now underestimated how bad things are. So they're comparing their results with the IPCC reports, which I think is so very important. So glad they did that. So what do they mention in the paper? Again, the notion of sea level rise from mountain glaciers. And this is actually quite in line with the IPCC's median projections for low emission scenarios. But for some regions, yes, we are underestimating the crisis. For example, in Southern Andes in New Zealand, it seems that the mass loss is already surpassing the worst case projections for 2040 in those two regions. I would like to share the conclusion from the paper because I think it is such a strong one. This underpins the IPCC's call for urgent and concrete actions to reduce greenhouse gas emissions and associated warming to limit the impact of glacier wastage on local geohazards, regional freshwater availability, and global sea level rise. That is the right way to conclude such a big paper. Thank you so much.